Thank you very much. We live in a most remarkable time. I think of this as a new renaissance, a time when we can come together and create incredible things that will have a legacy of many centuries. The Renaissance was special for many reasons, but it came out of communication. It came out of the sharing of ideas through the Gutenberg Press, the mass production of over 1 million books in the first year, the sharing of intellectual ideas, the sharing of political ideas that transformed the world. And I allowed academics and intellectuals and others to come together and create things, to make breakthroughs that were not possible before then. But it was not only a good time. In fact, in the long course of history, it was a disaster. It ended in the bonfire of the vanities, the burning of books, the Inquisition, the mass production of slavery, which is the greatest travesty that humanity has ever known. And look in the long economic history, there was no progress out of it. So the question of our time is, can we do better? Can we use this incredible connectivity that is now shared more widely because of cyber and other possibilities to create a new world where we overcome hunger, where we overcome disease and poverty? This is possible in our lifetimes because we all have collective genius in us. We have the opportunity to come together and share ideas and solve problems. This sharing of ideas is growing at an exponential rate. The ability to upload, to download, and to collaborate. And all the teams you'll be hearing from the Oxford Martin School today are sharing ideas globally as well as across disciplines in the school. And that's what makes this time different. We can make breakthroughs which were not even dreamable. That's why while you're here with us today, your life expectancy should increase by an average of 15 to 20 minutes. The breakthroughs that are happening in knowledge, in power, will make us healthier and have better lives around the world. This is converging around the world as well. So the possibilities of really the best time in humanity's history are there. We can do things. This is work from our Plants for the 21st Century group, which are doubling the root area of rice, allowing them to withstand climate shocks and other problems. So we can have technologies that help us, and we can share them more widely. But technologies are all dual use. This is airline traffic, which of course is fantastic. But it is also an exact replication of the spreading of the swine flu that came out of Mexico City. And work that our emerging infections group have done have shown this exact correlation. So our technologies that aid us also are the source of our systemic risks. The contagion. Derivatives were designed to spread and slice and dice risk, and they did that. They helped finance benefit many people around the world. But they were also, because they weren't understood, the source of a contagion and a systemic collapse that led to the financial crisis. It was the same technologies that brought good or bad. So we need to understand cascading risk, and that divided nations need to cooperate. This is the Aral Sea. Nations were doing the right thing. They were drawing water to feed their people. Each acting individually was doing a rational thing. Collectively, it was a disaster. And the story we need to take from this is that we have to collectively cooperate if we're to manage globalization and technological change. The Bretton Woods negotiators did a great job in creating new institutions, but they are now unfit for 21st century purpose. They are not able to meet the challenges of our time. They're not able to meet the challenges of climate change, of overused fishing, etc. The sorts of rearranging of the deck chairs that's happening in global governance remind me of the adage of rearranging the deck chairs in the Titanic. Too little is being done, too late, and it's not focusing on the big issues in a way that's going to make a difference to global problems. So we need to step up the game. But the problem is that we're in a very dangerous time in global politics. While there's a perfect storm in terms of resources and challenges, there's also a perfect storm in terms of the power vacuum. The old leadership are inward-looking, managing their own crises in the US, in Europe, in Japan, and the new leadership are not yet fit to govern. The technologies that we have provide possibilities, but we need to remember that electricity, with all its wonders, is the cause of our current climate change. It's taken us 200 years to realize what carbon does into the atmosphere. So the long leads and lags need to be accelerated, and you'll be hearing from colleagues about what we think we can do. We need to be more connected. Globalization is the source of the greatest solutions that humanity's ever known, opportunity, but it's also the greatest risk. And so how we develop a more connected world, which is more resilient, is the challenge of our time. If we can't solve this, we'll be more xenophobic, nationalist, protectionist, and we'll go backwards, which would be a disaster. So my question to the group is, how do we manage globalization to harvest the opportunity and not succumb to systemic risk? Thank you.
For most of human history, the major cause of social disruption has been hunger and famine. They've been the cause of most food riots over the years, but during our life, there have been really relatively few. Until the last few years, until food prices began to increase in 2008. Why have we seen this increase in food disruption? Partly, it's underlying demand. Population is going up and will go up further. But look at that graph. The red line suggests that populations will plateau around 10 billion people. The single most important thing that's happened in my intellectual life. But it's just not increasing numbers of mouths. It's that as people get wealthier, which is a good thing, bringing people out of poverty, richer people have fewer children, they demand more of the rich resource diets that we have in the West. So we have this major increase in demand occurring at a time where there are more and more supply side issues. Food production at the moment uses 70% of all of available fresh water. The 25% approximately of the soils that we rely upon for food in the future are being degraded. The nitrogen that washes out of agriculture pollutes our water bodies. We seem to be incapable of managing our fisheries properly. And as we'll hear from Tim a bit more in a moment, climate change is increasingly threatening our ability to produce food. And we're seeing that already with some of the extreme events that have occurred. And food isn't any other commodity. Food is essential for life. Food is a moral as much as an economic, priority. So what needs to be done? If you look ahead, if you look at the way food prices are changing at the moment, one can see an increase in food prices, which although relatively modest, this is the FAO Food Price Index, which only began in 1990, even a relatively modest increase in food prices and volatility that we've seen over the last few years have been sufficient to cause the disruption I talked about right at the beginning. And if one looks ahead, and it's difficult to look ahead to bring in together the different supply and demand side pressures, one has to use economic models, which almost by definition are wrong, but are the only ways that we have to look ahead. Then we can see, as this work which came out of IFPRI in Washington, some really scary things about where food prices may go over the next 40 or 50 years. If food prices go like that, we'll see more than riots. So what needs to be done? We need to have actions on supply, demand, and efficiency. We have to increase the pitifully low yields that we get in much of the developing world. Appropriate investment in the economic, the social, and the infrastructure skills could bring people out of poverty, could produce a lot of food. We mustn't relax about investing in increasing our ability to produce more food. Both high-tech, we have to persuade people that high-tech isn't a bogeyman, but also low-tech. We need to get food to be much more sustainable, as well as the social sciences. And research at Oxford is involved in all these areas. But it's not just production. We have to get efficiency better. It's folly to think that one can take food production outside globalization. We have to, as Stieglitz frequently says, make globalization work in favor of societal goods, such as food security. And we have to start by getting rid of some of the stupid market distorting subsidies we have in the rich world. We have to attend to waste. Probably a third of all food we produce is wasted. In the developing countries, largely on the farm and the food system, in the rich world, in our homes and our restaurants. Some of that waste you can't get rid of, but a lot you can. And we need to think about demand. They're really hard questions. It's literally impossible that a world of 10 to 11 billion people can enjoy the diets, the meat-rich diets that we have in the West. It's a really hard question. How can one change diets? I said at the beginning that one of the most extraordinary things that's happened in my adult intellectual life is the demographic transition. Population's going down. The second most weird thing that's happened is that you can no longer smoke in a French restaurant or on the French beach. If the French can stop smoking, then I think we can moderate our diets. So, looking ahead, I worry that we're sleepwalking into a resource crunch, food, but also water and energy. I worry that so much of the public and political discourse about food is fighting the battles of the last 50 years, not the coming 50 years. But at base, I'm an optimist. We've been there before. Malthus worried about these things in the 18th century. We worried about them before the Green Revolution. The real challenge is how can we feed a world of 9 to 10 billion people sustainably? Whoever does that, there will be glittering prizes. Thank you.
Thanks very much. I think certainly on geological timescales, we're now living in a period of absolutely unprecedented environmental change. The level of carbon dioxide emitted by burning fossil fuels is now higher than it's been for certainly many millions of years. And contemporaneous with increases in carbon dioxide, we're seeing increases in global temperature. Now, a scientist wants to know, are these things causally connected? What if we had not been emitting carbon dioxide into the atmosphere? Would the atmosphere still be warming? What if we continue to emit carbon dioxide into the atmosphere? Will we continue to see warming? Now, what if questions like this are the very lifeblood of science? And generally speaking in science, when we ask a what if question, we try to answer it with a laboratory experiment. So if we ask the question, what if we collide two protons together at almost the speed of light? We get the nations of the world to build a piece of kit down the road in Geneva to do this experiment and look for the results. But for climate, we're not in that situation. We only have the one world, and it's a global world. So the only way to answer these questions is through complex mathematical models, develop complex mathematical models of our climate system based on the laws of physics, Newton's laws of motion, and the laws of quantum mechanics. This is Max Planck. But climate is an incredibly complex system. We have to model not only the atmosphere and all the complex cloud systems that live in the atmosphere, we have to consider how the atmosphere couples to the oceans and the ice sheets. We have to consider the whole topography of the Earth, the mountains, the river basins, and so on, and the biology that goes with that. It's an incredibly complex problem. And so as a result, I at Oxford, or all climate institutes, don't have the computational power to deal with the problem in its entirety. So we end up with a rather fuzzy picture of the world in these mathematical models. It's a little bit like looking at a piece of text that we can't really see properly. Climate institutes tend to focus on individual words to try to see if they can see the big picture. But we can be misled by what we think the big picture is. So this is not a piece about meteorology, it's a love poem. So we need the resources to be able to see the big picture. And the big picture is really, what are we heading for? Are we heading for a world where climate change is something we can adapt to by investment in infrastructure? Or is it something that is going to be so catastrophic that no amount of adaptation is going to be beneficial? And we don't know that at the moment. We have predictions that are both ends of the spectrum. There is real uncertainty about this. And climate change, of course, is not just about temperature, it's about changes in precipitation. And again, when we come down to regional levels of detail, there is massive uncertainty. Large parts of the world, we don't even know with confidence the sign of the change in precipitation as a result of climate change. So my strong belief is, just as the world can get together to fund something like the Large Hadron Collider down the road, so we should be getting together to solve this clearly globally crucial problem, to provide the sort of infrastructure, in particular computing infrastructure, that we really can solve these equations at the level of detail that is needed. What are going to be the opportunities? We'll be able to provide much more detailed policy-relevant information on climate adaptation to local regions. In the UK here, we had 6 months of rain last year and 6 months of drought. This is a real problem for governments knowing what sort of infrastructure should they be developing. Geoengineering is increasingly coming onto the scene. Should we be spraying sulfate aerosols into the atmosphere to try to offset climate change? But again, the question is, what's going to happen to the monsoons? What's going to happen to the moisture supply to the rainforests? And we don't have enough detail in our climate models to be able to answer these questions well. And this is another key reason why we need much more investment in science. One of the other big opportunities is to be able to try to predict climate fluctuations on timescales of months to years ahead. Can we predict in advance the big drought they had in the US which affected food prices, for example? Can we predict the Russian heat wave that occurred a couple of years ago? Hurricane Sandy, Superstorm Sandy, has brought climate change, I think, back into the arena, the public arena and the policymakers arena. I just want to point out here that the best predictions of Hurricane Sandy were made with climate models that had the most structural detail. So we see a direct link between being able to predict and the level of complexity and detail in these models. So my idea is that, as I say, we should be developing a CERN for climate change. Nature ran a piece a few years ago endorsing this idea. So my big question, I suppose, to ask you is, what should we be doing to really try to understand the threat of climate change better? Thank you.
So this is bushmeat laid out in a West African market, available for purchase and inevitably consumption. Now we know that the HIV pandemic started from chimpanzee bushmeat. We also know that there are viruses out there in animals that will at some point possibly cross over into man and create new pandemics for the future that we may need to tackle. However, today I want to challenge this assumption that it is these new epidemics that we need to worry about. Rather than the rainforests of West Africa or the civet cat markets of Asia, the threats that face us at the moment are with us now, and to some extent have been engineered by us and the way that we have treated infections. So this is going to be a call, if you like, to hold back on the horizon scanning and to think inside the box for a little bit. Because the way that we have managed infections with antibiotics and antivirals, although very successful, has created new problems and has changed the infectious diseases landscape. And I'm going to illustrate this by talking about antibiotic drug resistance and the HIV pandemic and how that has changed. Urinary tract infections and chest infections. These are the meat and drink of the attending general physician in general hospitals. They should be easy to diagnose. They should be easy to treat. But what we are finding is that this is changing. The sort of antibiotics we would routinely hand out to treat these infections are starting not to work. This slide shows my hospital in rural, leafy England. It is Normalsville. Normal patients, normal demographic, normal clinical presentations. And yet, even here, we are finding the antibiotics we would use to treat these infections aren't working. We're admitting patients for intravenous therapy where tablets would have worked before. And we're finding even then sometimes isn't working. We are entering a post-antibiotic era. Now, it's not just infections that we may not be able to treat. If the antibiotics don't work, there'll be no operations. There'll be no chemotherapy. There'll be no transplantation. The WHO tells us that antibiotic resistance is one of the 3 greatest threats facing mankind at the moment. The solution is for the pharmaceutical industry, for academia, for government, for policymakers to work together. But that will only happen if the right incentives are in place for all of them, and there is protection for things around IP to make that happen. The Infectious Diseases Society of America want 10 new antibiotics by 2020. That is a huge ask and will only be achieved if those are in place. I want to talk for a few minutes about the HIV pandemic, because this is also changing, and it's changing because of the way we have managed it. Fantastic success through antiretroviral drugs and thousands of lives saved. However, for every 2 people starting antiretroviral therapy, there are 5 new people infected. The balance is going the wrong way. These are AIDS quilts laid out in Washington to commemorate those who have died of HIV infection. And yet the scene is changing. HIV is turning into a chronic condition. People started at the right time of therapy have normal life expectancies. They will not become ill, but it is going to cost billions of dollars. It is untenable as it stands at the moment. The solution is what we're told about all the time. There is potential for prevention. Don't take risks. Maybe don't catch HIV in the first place. But as a species, we are risk takers, and we know that at a public health level, changing human behaviour is pretty much impossible on a grand schema. The other solution would be to try and imagine doing something that could be impossible, and that would be to find a cure for HIV. HIV is a persistent virus. It stays in your body. Therapy has to be for life. You stop taking the drugs, the virus comes back again. If you could find a cure, we could potentially solve these problems and cope with all the problems I have raised. The problem with HIV is like this spider. It hides inside the body. It integrates into our very DNA. It becomes part of us. And by doing that, it stops being a target. If you don't have a target, how on earth are you going to develop a therapy against it. But this next slide is going to show you the Berlin patient. This man is remarkable. He is the only man on the planet who has been cured of HIV infection. But the therapy to do it nearly killed him. And this is where we have a problem. We have people who are otherwise potentially going to have normal life expectancies, but in a societal way we cannot manage this. And yet the research to do this and to sort this out is going to impose risks upon these people. So as a society, what risks are we willing to take? When we flex our medical research muscles, we must say at first, do no harm. And this is the problem we are currently faced with at the moment. How are we going to take this forward? And how do we find the balance of cure, research, and then the risks imposed on society? The solution, I suspect, lies in the realm of big data. There's fantastic new technologies about viral sequencing and genomics, about seeing what a single cell in your immune system is doing to fight infections. And I think over the next couple of years we're going to see some incredible breakthroughs. And I think there will be more cures of HIV that we will hear about. But how can we take that to a bigger level? And so the question I'm going to leave you with is that how are we going to identify and tackle these new medical threats? So thank you very much.
So the truth of the matter is that all of us as individuals exist in cyberspace. In fact, it's quite entangled. You would be hard pushed to be able to pull apart your physical instantiations and your digital instantiations of yourselves at home, at work, across modern society in the developing world. And it's not just science that requires cyberspace to solve tomorrow's problems, but we depend upon it for our transport systems, for our healthcare. It keeps the lights on, education, food, your work, your communications, satellites, moving people around the planet. And this is critical. If you think about modern cities, you cannot keep the city moving. You won't keep the lights on. You won't keep the transport systems going and the people moving around and living their lives without protecting their dependence on cyberspace. And so the question that concerns me is around how we secure this future, but it's very challenging. We live in a world of hyperconnectivity. All of these systems via the internet or via people are getting connected, and they're very complex and they're moving and they're stretching our security paradigms. We know today that our current paradigms will not scale to this level of complexity. And the vision for the future, the kinds of numbers and statistics that are being proposed, this is 2020 according to somebody, IDC, literally the amount of data that we're going to be producing and putting out there in cyberspace is going to be huge. And so when we worry about how we protect the data, how we protect the algorithms that use that data, we're very concerned. But it's not just a big problem and a problem of growth, it's a problem of miniaturization. What you see here is an image of a nanobot, the size of a red blood cell. Some of this nanotechnology, you can't even detect its existence. So if it was made malicious, if it became the new carrier of digital viruses, what would that do in terms of securing cyberspace? And unfortunately, whilst we embrace this complexity, while we have to scale up and scale down, our adversaries are simply growing in skill. They're not reactionary, they're strategic, they're planning, they have supply chains, and they can make money. And unfortunately, they're not all obvious. They don't walk around in balaclavas. It's not always easy to spot the person that would do you ill. And some of these adversaries are existing in your systems for very long periods of time before you even know that they're there. And unfortunately, the hyperconnectedness means that both large societies, organizations, right down to the man on the street in your cars, your walking iPhones have to be concerned. Some estimates believe that 40% of the threat is emanating from inside. That's like asking you to look at the street and understand who in the street would do you wrong. Some of them might be your cleaners or your trusted partners. So what are the consequences for us? If we don't worry about how we protect cyberspace, unfortunately, it could be catastrophic for us in the future. It may not just undo our ability to solve some of the world's problems. It may simply undo our ability to function. We've recently experienced what it might be like if we had a collapse in the financial systems. But what would happen if the planes were all grounded? I did 10 hours of that yesterday. But in general, what would happen if all of the blood groups were changed in the hospital databases so everybody was too scared to go and get operated on? There were no food on the shelves. You couldn't reach work. You couldn't get to schools. You could no longer communicate. The truth of the matter is cyberspace is an environment, and we have to worry about sustaining it. There's no neutral position. It will get eroded, things will melt away, and it will cause problems for us in the longer term. And so we need to think about how we do governance. And today, it's like a Wild West. Cyberspace does not respect national boundaries. Current forms of governance driven by national boundaries are not going to work directly. The truth of the matter is the custodians of cyberspace are as much in the commercial sector and are as much you and the people walking down the street as they are governance. And so if we look at the kinds of mechanisms we've embraced historically to address these global issues, like the Kyoto agreements, we're failing to deliver. We know that we've committed to things that we are not delivering on. And so my big question to you today is, how do we deliver the kind of partnerships that will deliver the real meaningful governance for the cyberspace of the 21st century?